Hi, everyone. My name is Troy Kent. I'm a threat researcher with Awake Security, and today we're going to talk about exfiltrating data with crypto miners. I came up with this talk while hanging out with a couple of my friends in the industry over beers, as one does, and we started talking about the alerts that we were seeing in our security operations centers, either that we worked in or work with, what have you. We started off talking about the types of alerts that we're seeing, the kind of interesting things that we're seeing, the changes between now and a couple of years ago. And one of the things that came up was the kinds of alerts that our analysts are seeing over and over again every day that are starting to become a nuisance, so much so that it seems like analysts are actually dismissing those types of alerts as having the possibility of being malicious at all. So today we're going to talk about how our SOC analysts respond to different types of alerts, and then how we can take advantage of that as an attacker. We will show how we can use open source software to exfiltrate data. We'll show why it would be effective in today's SOC environments. And then, of course, we'll talk about what we can do as an industry to fix problems like these. So, how do we respond to alerts? Or how do our analysts respond to alerts? Do they perform further investigation? Do they take the machine offline and duplicate the hard drive? Do they run a remote scan and move on with their day? Do they re-image the machine and move on with their lives? Well, hopefully that all depends on the severity of the alert. But that leads us to ask, what determines the severity of alerts? Typically, it's business costs. So of course, if we have any reason to believe that it's APT, then it's #1 priority, right? If it's targeting the company, then that's more interesting if it's targeting a user, or if it's targeting a user that's very high up in the company, or if it's a pup or nuisanceware. So all of these things, depending on what the answers are probably going to determine what the severity is, and therefore determine your response. Now, during our conversation, or my conversation with my peers, one of the things that popped into my brain, as I mentioned, was how do we respond to that last bullet? So the pups and the nuisanceware, the stuff that our analysts are seeing over and over again, and every time they analyze it, it's benign or it's not something that has a high priority. So how do we respond to that last bullet? In those cases, do we just re-image the machine? Do we run a scan and move on? Maybe it came back with a detection and then it removes it, and so you figure you're good to go. Maybe it comes back without any detection, so you assume that it was already taken care of, or that maybe it was a browser plugin or something that's no longer there, or something happening in the browser rather than a client that's actually been downloaded. Or maybe you do nothing at all. And so in my experience in SOCs that I've worked in and SOCs that I've worked with, especially over the course of the last year or so, as I've had this on my mind, I asked them, what do they do when they run into these kinds of things? And I found that it was usually one of these 3 things and not much more for these types of alerts. I saw, re-imaging machines might happen in more strict environments. I might see, running a scan and moving on if they have the ability to do so remotely. Or sometimes for these types of alerts, we'll say, well, whatever, it's a pup. Virus Total calls it a pup. Whatever, they downloaded a toolbar, they downloaded some stupid game. I don't really care. And they'll move on, and they'll move on to the Trojans and the downloaders and the exploit kits and whatever else they're getting in their alert queue. So now I want to ask us to put on our hacker hoodies and think about how we can take advantage of the analyst response to that last bullet. So how can we take advantage of the fact that they get these alerts over and over again, that they have alert fatigue because there's so many alerts to respond to? So my proposal is to create malware that appears to be a nuisance. So we want to make sure that it looks like a nuisance on the network. We want to make sure that it looks like a nuisance on the host. We want to make sure that if they do any further investigation, that it still appears to be that nuisance. And in other words, we want to be detected on purpose, but as something that can be easily dismissed. I think a really good example of this is crypto mining. So crypto mining is one of those alerts that our analysts receive potentially over and over again. It's becoming more and more common. We've seen plenty of articles about it because it has a good return on investment for attackers, probably more so than ransomware, since if you're mining coin, even if they catch you, you already have you made some money, versus ransomware where they have to actually cave into the ransom or what have you. Or if you're stealing credentials, then you have to get a little bit more creative. But crypto mining is basically you install it or you run it and you get profit. So we see plenty of these alerts since it's proliferated over the last couple of years. However, our response to them in our security operations centers are typically that it is a nuisance. They may be interested if it's a client installed on a device and it's not supposed to have any other, it's not supposed to have any corporate, They might be interested if it is a downloadable client installed on a device where you're not supposed to be able to install third-party software, for example. But other than that, they, on the whole, they didn't seem that interested. But other than that, it seems like mostly the response is that it's a nuisance or a corporate privacy violation or something that's just not as interesting as traditional malware. People are aware that it uses resources, it uses their hardware, but they don't see it as much of a business risk as, say, stealing of credentials or even the installation of some kind of worm that can damage their infrastructure. So here's what I did. I took an open source miner, in this case XMRIG, which is a Monero miner, and I edited it. I created a mechanism to exfiltrate data. While I was doing this, I made sure that the exfiltration method looks like a miner on the network. So in this case, it's using the mining protocol Stratum for communication, and it's using the mining pool as a C2 server rather than an attacker-owned C2. This is what you would expect from actual mining traffic. I want to make sure that it looks like a miner on the host as well. One way to make sure of that is to, mine coin. But more specifically, we want to make sure that we're triggering mining host-based detections, which is what the analyst is going to use to initially determine that it's mining traffic, and potentially, if they do further investigation, determine that it's mining traffic by maybe uploading it to VirusTotal or something like that. And of course, at the end, we're going to make it fileless because we can, and it's easy, and it's fun to show. So here's how we're going to do this. So here we have a screenshot from Wireshark of Stratum, which is the protocol that XMRIG uses to communicate with the mining pool. And you'll see here the string, this can be anything, in the pass field. So this pass field, the reason why it says this can be anything is because it can, in fact, be anything. You'll see a screenshot of the mining pool dashboard there, where the worker value is filled out with the value. This can be anything that was entered in the pass value. Even though pass would lead you to believe that it's a password for the mining pool, it's not. It's typically used by pools as the worker value. Usually you don't need a password to log in or authenticate with these mining pools. They simply use your wallet address. And so since we can make this field anything, we have a couple of options. The first obvious option is that we can send data in that field. So if we're using a miner and we pass the pass value to the miner, and that value is actually someone's password, for example, then we can send information in there, right? It will go to the mining pool. It'll be sent in that Stratum protocol. And as an attacker, we can go look at the mining pool dashboard and retrieve those passwords. The downside to that is that if someone is looking at this traffic, if they do decide to do further investigation, which may not be likely, then they might be able to see clearly that there's password values in that pass field. You could encode the data to make it less noticeable that they're passwords, but perhaps if someone's familiar with the protocol, they might recognize that it's odd to have something other than a readable string in the pass field. However, there's probably a good chance that not many analysts are familiar with this protocol, so you might be okay doing that. However, for the sake of argument and just to show what's possible, I wanted to do something that I thought would be even more evasive by sending data using that field. So rather than having our exfiltrated data in that field, we're going to have two different values in that field during the entire exfiltration process. So if someone looks at the traffic, all they're going to see are those two different values. They're not going to be able to decode the information that we're sending unless they know how we're sending it. So here's the way that it works. To demonstrate this, I created a wrapper for the mining software to basically start it and stop it at specific intervals. On the left-hand side, we see the client wrapper starting. Those asterisks and then those timestamps are basically the miner starting up and then a few things being done and then shares being accepted by the server. And what happens when you're mining with a mining pool is that rather than trying to calculate a coin on your own, you perform a share of the work across all of the different workers that are submitting to this mining pool. And then whenever a coin is finally mined, then you get, an amount of that coin representative of the amount of shares that were accepted by the pool. So, and you see it doesn't take too long to calculate shares. That's why I chose to use this. So the way that it works, client wrapper is started. And then once a specific number of shares are accepted by the mining pool that are indicative of a specific byte using the encoding scheme that I used, then it switches to the second worker value. So the miner will restart with the second worker. You can see the text being indicative of the miner starting up again with the asterisks and then timestamps again as the shares are accepted by the server. Then once another number of shares are accepted with the second worker value, then the miner is restarted again with the first worker value. On the right-hand side, we see the script that the attacker would be running on his own device that's communicating with the mining pool using the API that's available for that mining pool to pull down information about the workers. Different statistics can be pulled down, like the amount or the hash rate, for example, or how many shares have been accepted for that particular worker. So that's how the attacker can pull down the number of shares that have been accepted for the first worker and the second worker, and then make out what the exfiltrated data is supposed to decode into. You can see when that worker changes, the byte is recorded. So you can see the byte, or the value 3 being found, which in this character encoding scheme that I'm using is the character B. So again, it's important to recognize that all you're going to see as an analyst on your network is that there are two worker values being sent, there is mining traffic occurring, and the mining traffic is going to the mining pool. So what does this look like on the network? So I captured a PCAP of this traffic and I uploaded it to packet total. Right here you can see cryptocurrency snort alerts for ET policy cryptocurrency miner check-in, which is technically what it is, so it's not wrong. And it even does us the favor of de-emphasizing the alert by calling it a potential corporate privacy violation. Think realistically how the analysts and your security operations centers are going to respond to something that's been labeled a potential corporate privacy violation, especially when they have a number of other alerts that sound more interesting, like potential phishing or malware infection, Zeus Trojan, things like that. Are they going to spend a lot of time on this potential corporate privacy violation? Or are they going to spend as little time as possible on it? On the right-hand side, we see a screenshot of the mining pool dashboard again. And you can see those two worker values that are now in that dashboard. You can see the workers are actually performing work. They're calculating the shares, and the shares are being accepted by the server. Now, the attacker wouldn't retrieve the information from this dashboard. This is just to show you a visual representation of it. So we talked about the network. Let's talk about the host. So I mentioned that I edited the source code of an open source miner, which in this case is XMRIG, again, is a Monero miner. And here's some of the ways you can do that. So you can download this from GitHub and you can make whatever edits you want, build it, run it, make sure that it works. So here's a couple of examples. You can hard code command line options. So I mentioned in the beginning that we're going to make it fileless. XMRIG typically requires you to have a configuration file on disk in order to run. However, you can overwrite that and hard code your command line options, which then makes it so you can create a fileless version of this, so you don't have to have that configuration file. If the defending network is logging commands on the command line, then this information here won't end up there like it would if you were to actually run the command with the options. You can open files, so you see an example of opening etc password. You can stop loops. So this crypto miner uses something called libuv, which I don't know a whole lot about, but it's some kind of looping library that allows different loops to run over and over again without stopping. And so in the example where I said we could send data in that pass field, it would probably be more efficient to simply log in using that login method with the pass field, and then quit out and then go back to log in again with the second part of the information and continuing until all the information is sent or exfiltrated. So the best way to do that would be to wait for a successful login and then go ahead and stop the loop and start again. And so that's as simple as Googling around, figuring out what the code is to stop it, and then finding that code in the source code of the successful login and adding it in there. You can also execute arbitrary commands. So here's an example of executing ls. I'm sure you can think of more useful commands as an attacker. So there's a couple of takeaways here. First is that I'm not a programmer. I was certainly not a C++ or C programmer. XMRIG is written in C++. However, I was able to search around and easily find solutions to the problems that I had. How do you open files? How do you stop loops? How do you execute commands? It's as easy as searching Stack Overflow, basically copying and pasting the code in there and running it. Another interesting thing is that while I made these edits and uploaded them to VirusTotal, no matter what edit I made, VirusTotal still detected a miner, or at least the vendors on VirusTotal still detected a miner, and only that. You can see at the bottom, that's the binary that I had edited, or one of them. You can see Bitcoin miner, PUP, a variant of coin miner, Bitcoin miner, PUA coin miner, not a virus, risk tool OSX coin miner. So again, it does us a favor of de-emphasizing the alert, calls it a PUP, calls it not a virus. And again, these are binaries that have been manipulated and changed so that they can do things like open files and run arbitrary commands. I also uploaded the Python wrapper that I used in the first example, thinking that I wouldn't have any detection, so I could share that with you. But to my surprise, it did come back with detections, also for a PUP coin miner, not a virus. I'm not exactly sure why. My guess is that the string XMRIG is in it somewhere, because it's not actually doing any mining. It's just controlling a miner. So, but either way, there's detections here that point to it being a miner. So again, think about how your analysts would respond if they received alerts from their network IDS that says, hey, you have a coin miner from this device. And then they find that binary, they upload it to VirusTotal, or even they find a Python script and upload that as well. And they see, oh, okay, yeah, it says it's a coin miner too. What would their response be, do you think? And as I promised, using a little bit of PowerShell magic, we're going to make it fileless. So all I did here is I used the PowerShell invoke reflection script, which you can find in PowerSploit or Empire. And I took the base 64 encoded version of the mining binary, embedded it in that script, and then hosted it on a web server. Then I used invoke expression to run that script, which is then, it pulls the binary into memory and runs it from there. And again, we edit it so it didn't require a configuration file, so that's why we're able to do this without even downloading the config file. Now this might make it more suspicious to an analyst, so you may not even want to do this. I just wanted to show how easy it was to do. You can see the asterisks there, indicative of the miner starting up. You can see the timestamps again and the first share being accepted. So it's the same activity that we saw with the Python wrapper. The only difference is that we're using a PowerShell wrapper in this instance. But yeah, I wanted to demonstrate how easy it was to do. Basically, this was a few minutes of Googling around how to run binary reflectively or how to run in memory or what have you. And I found the line of PowerShell that I needed, hosted the web server or hosted the file on the web server, and that was it. So maybe the most important thing, what do we do about it? We could parse and detect coin mining. You're probably already detecting coin mining. You may or may not be parsing it. My guess is that you're not. However, if you go through the trouble of parsing it, then that doesn't do you any good if it's encrypted. Then we have to look at other methods to try to detect what we're looking at. And it doesn't change the fact that even though we could go through the efforts of maybe parsing coin mining, maybe using TLS fingerprinting for the times that it's encrypted, or even just using snort rules or what have you to detect mining. Just because we're detecting mining and just because that would detect this example of nuisanceware being used maliciously, it doesn't prevent other pups or other nuisanceware that isn't crypto mining from being used the same way. And so my overall point is not that you should be scared about specifically coin mining or that you should be scared at all. You should just be cognizant of the fact that it's possible to use analyst assumptions against them so that you can repurpose potentially unwanted or nuisanceware to do something malicious. So we could respond to coin mining and other nuisances as legitimate threats, which is probably a good idea. As I mentioned, it's important to be cognizant of the fact that this kind of stuff is possible. However, is it scalable? When you have thousands of alerts already, maybe more, is it scalable to then add all of these other nuisanceware things to your workflow? Or even if they're currently technically there in the form of alerts, is it scalable to then start taking them seriously or doing a further investigation every time you see one? My guess is probably not. So what I would propose or suggest is to use behavioral detection of exfiltration in C2. Just a basic example, lopsided communication in a host favor means that, well, it's downloading something, right? Notable communication for devices or applications or for your network. So things that are interesting for a device or things that you don't normally see sourced from one application you're now seeing, or something you've never seen in your network before. That can be interesting information. However, it's important to use all of that or all of these behavioral aspects of exfiltration and downloading together to pinpoint the things that are actually interesting. Because if you alert yourself every time you see new communication that you've never seen before, that's going to create a lot of noise. I'm sure we've all seen plenty of ad network traffic to things that are unique that we've never seen before, maybe domains that were registered 2 days ago, but it turns out to be advertisement traffic. And so simply just saying, anytime I see new behavior, let me know is not enough. And simply saying, every time I see something that looks like a download or something that looks like an upload, let me know. It's using all of those things together and comparing all the traffic across your network to each other is where we really can find these types of things, regardless of whether it's a crypto miner or potentially unwanted program or something else, commodity malware, custom malware. And it's important that we improve analyst workflows and avoid confirmation bias. So in my experience, it's more frequent that analysts are evaluated based off of the number of alerts that they process, not the number of threats that they find. And when it is expected of them to process a large number of alerts, but impossible to process them all efficiently, then the alerts that are less severe or that don't appear worth their time or that people have marked as benign in the past, hence confirmation bias, then they're less likely to spend time on it this time around so they can make sure that they process enough alerts. So it's important that we empower analysts with the correct tools, that give them the right context, that show them information that is actually pertinent to what they're trying to figure out, to their investigation, reducing the noise that they have to sift through, and giving them basically stuff that is, and basically giving them things that are actionable, things that they can process, things that they don't have to spend, multiple hours trying to figure out, or things that they're just going to dismiss because they don't have time to do it anyway. So we need to make sure that we're giving them tools that answer the questions that they have to ask in order to complete their investigations. So if they receive an alert, then we want to make sure that they can ask, is this alert that I received something I should be concerned about, or is it not? That way they're not spending too much time on a specific alert. We also need to make sure that we're giving them the correct alerts, so they're not spending 90% of their time processing alerts that amount to nothing. Things you should take away. So we don't always respond to alerts sufficiently. So using third-party C2 servers or for exfiltration is not that complicated. We've seen it before using Twitter and Gmail for C2 servers. Now I'm showing you an example of using a crypto miner for exfiltration to a mining pool. It's not that complicated to do, and I'm sure there's plenty of other examples that we could come up with of using some third party that is typically benign or at least dismissed as a C2 server. Host-based and network-based static detection is extraordinarily simple to fool. So this is not new information. We've been saying this for a long time, but we're still using these tools. We're still using what VirusTotal tells us, which is not a bad thing necessarily, but it's an easy trap to fall into. Behavioral detection is a more reasonable solution than responding only to this example. So we could go the whack-a-mole route and listen to the fact that I've told you it's possible to exfiltrate data with a crypto miner and then be scared about crypto miners. Or we could look at this as one example of what could potentially be many of examples of using nuisanceware to exfiltrate data. And then we can look to using more advanced detection, more advanced tools that can detect behavior rather than simply signatures, and hopefully give us the right answers in our investigations. Thank you. Again, my name is Troy Kent. I'm a threat researcher at Awake Security. There's my Twitter handle and my email if you have any questions. Thanks for watching.